So I just record. Yeah.
All right, I'll go ahead and start. Hello, everyone. So we're going to be going over sort of what the cloud is at a very high level, and then we'll talk about very specifics about how everything's set up in AWS and Azure to hopefully ease that process and then provide you with later on slides to reference. Okay. So we'll go over what is cloud computing, where does cloud computing fit into the machine learning end-to-end pipeline, some like computer hardware and where that meets software, components and jargon that will be used, and then talking about our specific cloud computing tools. Okay, so cloud services are this like mixture of things, and AWS and Azure, it seems like tends to really bombard people. So they have all of these different services that do all of these different things. They sell infrastructure as a service and software as a service, among other things. So infrastructure as a service is like what we're using, so VMs and disks and storage space. And software as a service is like deploying Lambdas and using GitHub and being able to run all of your software not on your machine. And then it also serves companies, like it's used so much because it eliminates a lot of IT infrastructure. So people can get going quickly. If they run into IT issues, they can sort of shift it to Amazon and Microsoft and Google to take care of them. So that's part of the reason why cloud computing is so prevalent today. They have a pay-as-you-go pricing model, so kind of like your electrical bill or your water bill. It's based on usage and not just like one flat bill. And then the elasticity of the cloud. So you can have like $1,000 machine that runs for 1 hour that's super, super powerful, or you can have 1,000 very, very, very cheap machines all running parallelly. So it's like provides a lot of flexibility and it provides a lot of power. And then another reason why cloud computing is so popular is that a lot of places care about robusticity and availability. So you can say, I want my cloud computer to be in Oregon and Virginia and in Asia and like all over, and they can sort of serve as places where it can work one place and then it can go down in another place and it can still power through it. Okay, so how this fits into the end-to-end machine learning pipeline. So I'm just going to go super broad here. So the end-to-end machine learning pipeline is you collect data, you process and clean it, and like do feature extraction. You train an ML model, you validate and evaluate the ML model, you deploy it, and then you evaluate it on that deployment. And then this process repeats until you're satisfied with what you have. So in the cloud, for us, it's like focused on this part. And then like in this summer school, we won't do processing, cleaning, or feature extraction in the cloud. We'll do just training the ML model and validating and evaluating the ML model. Okay, so yeah, we'll cover in AWS and Azure, we'll cover like generally what everything is, and then we'll go into specifics on data storage, VMs, and then model training. And then model evaluation will be done in the cloud, but it will be covered in another lecture. Okay, so what is the cloud? It's like, so if you say, I want a server in California, or I want something in California, it's just it's just a server, and you communicate with the server via like command prompt. So, and then you also have, so server powers compute, storage is just like where you store things. It's like a really, really fancy SD disk. And then you upload your data to your storage, and then your server provides as many VMs as you want. So a VM is a virtual machine. You can have as many VMs as would take space on the server to be there. So VMs can connect to storage, they can connect to the server, they can talk across, and then servers can talk to storages directly if they're in the same region. And then, like, how do you communicate with everything with code? We'll be pushing things to GitHub, and then, sorry. I clicked on the link. Okay, we'll be pushing everything to GitHub from your laptop, and then pulling everything down from your VM, and then going back and forth in that process. So yeah.
You mentioned in the beginning that the server's in California, for example. Why does it matter geographically where it is?
So it's like time of response. So if you're physically located in California, then you don't want your server to be in like Africa, just because like your response, like
Data transfer?
it's just response time. So it takes longer for a signal or a message to get sent that far away than it does if you're communicating with like Northern California. So it's just physical, like geographical distance.
Thank you.
Okay, so virtual machine, this is a super high level. It's mainly for like interest. You guys can absorb however much of this as you want. But there's like a machine that's running an operating system, and a virtual machine is a way to emulate a different operating system and then have full control over your computer without actually having, so it's like you have your operating system at the base layer, and then you have all of these things above it, and then you have your like virtual machine capabilities, and your virtual machine lets you install a different operating system, lets you install however many libraries on that different operating system, and lets you use as many different applications. So it's used for deploying applications on the cloud, testing on different operating systems. So if you want to say develop an app in Windows and Mac and Linux, you can do all of that with virtual machines. And then it lets you just like back up existing operating systems. Compared to containers, containers are one level up. They're things like Docker and Kubernetes. We won't deal with those in the cloud. This is only for like frame of reference with vocabulary and everything. And then Jason will get a little bit more into this in the deployment phase. But containers are one step up. So instead of controlling like an operating system, you're controlling all of the applications and the libraries on a system. And that makes it really easy to deploy and like use other places, but it doesn't make it operating system dependent. So if you want to like install something on your Windows machine, it doesn't make it like one way or another. And yeah, so examples of these are like Docker, Kubernetes, and then Azure container instances. A container, so we're going like up in terms of hardware to more software levels. But the comparison from a container to a Python environment, as you guys have like been introduced to Anaconda and like environmental things, no pun in that. But a Python environment just controls like the libraries that you install. So if you don't care about like your processes running or the operating system being isolated, and you just want to be able to say, okay, here are all of the libraries that I used for my work, you would use like a Python environment. Okay, and then the way that containers sort of fit into this big picture is that all of the things on the right are a container, and you can have several containers on a virtual machine, but you can also, like say you take this container, you can move it just as it is to a different virtual machine and run it on that other virtual machine, and it'll run just as is.
So would you use containers as kind of like a fail safe? Like if you had one virtual machine go down, you could just say, I'm gonna take this container and move it to a different.
That is one way to use
Okay.
them, yeah. Okay, so with Azure and AWS today, AWS has something called S3. It stands for Simple Storage Service. It's just like, imagine a external file system. Similarly, Azure has blobs. I don't know why they're called blobs. That's what they're called. And then AWS has, for virtual machines, AWS has EC2, stands for Elastic Compute Cloud. I guess they're like advertising the scalability of it, hence elasticity, and Azure just calls it a VM. Okay, so data storage. If you guys all want to get out your computers right now, we're gonna be like really walking through all of this. We'll go over AWS first, so the Azure folks can kind of sit tight, and then we'll go over Azure.
You should listen to the other one though, because one, there's a lot of consistency, and two, you can opportunistically get research credits from these different organizations depending on who has them available, so it's good to be able to use both.
You can also be like, AWS provided me all of these credits for this research project. It would really be nice if Azure did, and they'll like compete as I've come to learn.
Is that common? Like, who like talking about?
I don't know. I mean, I've
To
just
get research credits.
Or for the matching?
I think that's probably something that you would have to learn. I don't know if there's like a general portal.
Oh, okay.
But if you knew the right person.
That sounds sweet.
yeah. Well, I think it's like they just escalate it. So
Nice.
Is that what happened for the credits for the summer school? You were like, oh, Azure gave us some money.
Oh, it was that we got commitments from both, and then one of them was like, oh, that person who had committed like left, and we were like, well. Yeah, so like we'd officially like had them commit to have the funding, and then there was like some gentle complexity in actually getting it. No.
okay, cool. So if you guys all of you AWS folks go to the console and then go to S3, find the S3 service.
Yeah.
And then in S3, click create a bucket.
Bucket for.
Yes. You got it, yeah, I know. And then, so I'm gonna go over this kind of quickly, because we have to get through both services, but all of these slides will be available to you. So if you create a bucket, you name that bucket, whatever you wanna name it. So I named mine CV for E Cloud Lecture. And then it'll have a lot of like, how private do you want this to be? For simplicity, I just made everything public. I would encourage you to do that if you're doing this during this lecture, but we can talk about it afterwards if you want to make things private for your own data. I will say it's really, really hard to like access a bucket if you don't know what its name is, or like if you don't have the right like SSH capabilities. So there is some like security and obscurity, but yeah. Okay, so note that I'm using this US 2 region, or US West 2 region. Typically you want in AWS services, you want to stick with the same region, because then it'll drive down the cost. If you switch regions, data transfers from like S3 to EC2 machines will be priced higher. Yeah. Okay, and then so I create this bucket, and then it shows up in my like list of buckets. It should be automatic. And then once a bucket has been created, you can like click into it, and it should show you like something that looks like an empty system. So you can either upload manually, where you can like drag and drop from your file system, or AWS has like an 150 meg limit, I think. So then you'll have to download the command line interface. So we'll go through that. So you can go to this link. Again, these slides will be posted. But if you don't have the AWS command line interface, this link has instructions for all operating systems for how to download it. You will need to be able to download it. So like, if you have problems with that, come talk to us afterwards. And then after you download it, you type in, or after you download it and go through the steps to like install it, you type in AWS configure. It'll ask for a secret access key, a key ID, a region name, and a default output format. How do you get your secret access key? You go to your AWS console, you click your name, you go down to security credentials and click on that. That brings up all of these things. You click on the like access keys field and go to create a new access key, click on that. And then that'll say like, that'll bring up a pop-up and ask you if you want to download your .pem file. Your .pem file just has your like, download your key file, sorry. And that just has your access key and secret ID, or key ID and a secret key. So you download that, you open it up, it'll populate with a CSV, which I can't really show on these slides because it's like secret. But then it has like a AWS access key ID equals something, you copy the equals. Same for AWS secret access key ID, you copy that into your terminal in AWS configure. For default region name, I typed in US West 2, that's where I created the S3 storage. And then default output format, you can either type or leave it as none, which is like the default, or you can type in some other output format. So I typed in JSON. Yeah.
Just for clarification, this uploading via command line is something the students should do at a later point if it becomes necessary and not right now during the lecture.
I mean, if they can do it right now, like power to them. They don't have to, but also AWS limits you with upload sizes. So if your data is like greater than 150 megs, you'll be forced to download the exit or command line.
Okay.
For those of us using Windows, do we do this via the Ubuntu terminal if we have that
You
now?
can do it via the Ubuntu terminal. There are also instructions from Windows, and it'll similarly be like an AWS configure.
Okay, so it doesn't matter which you do it on? Okay.
All right, and then in order to actually upload from the command line, you go into your bucket. I always create a folder in my bucket as like the first thing that I do. Otherwise, I find that like things get really messy really quickly. So I create a folder, and then once that folder has been created, I click like the little check mark next to it and say copy S3 URI. And that'll give me the S3 URI. And then to upload a file, it's just AWS space S3 CP source path to the S3 URI path. And then to copy a folder, it's just this AWS S3 CP -- recursive source to destination. Again, all of these slides will be available like immediately afterwards, so you guys can follow along too. And then once it's uploaded, it'll show up in your bucket as the file name and the folder. Okay, now yeah.
So I was just gonna ask, when you're uploading images or, whatever your data is like, should you put it in certain folders, like in relation to like test set, train set, or does it just all go in together and then you?
So this kind of goes back to what Jason was talking about yesterday. You don't want the depth of your folders to be too like big, but you also want to be able to differentiate. So I would probably do like a train set, test set
Okay.
kind of split, but then within those folders, I would keep it really, really broad.
Yeah. Okay.
Okay, now Azure folks. So you're gonna go to the portal. You're gonna press, and I'm like really, really close to your guys' level with this. So I'm like very new to Azure. So you're gonna click on storage account and then press like create new. I know that a lot of you guys have done this since I looked at it last night and I was like, yes, my Azure people are. And then, so you go to containers, which is down here in the drop down. You press plus container to create a new container. You name it, and then create it. And then to start uploading blobs to it, you can either do it manually, like in S3. I don't know why, but Azure doesn't say their limit as like clearly as AWS does. I don't really know what Azure's file size limits are. But yeah, you can either do this manually, or you can also do it from a command line interface. So here's the link to download that. Azure's documentation is super, super good for like at least this stuff. So they have like how to download on Mac, how to download on Windows, all of that. And yeah, so it'll be like, so you'll download the command line interface, and then instead of doing that AWS configure command, you'll do an AZ login command, which I guess you need really good internet for, or you need strong enough internet for so that it can like reach wherever it reaches in Azure. That will open like a browser and prompt you to click on whatever account you want it linked to. And then it'll say, presumably, like you have successfully logged in. And that's all you need to do for this AZ configure, like equivalent or AZ login. All right, so the way that you upload data in Azure via the command line is either through this AZ storage upload set of commands, or you can download AZ copy. I found that downloading another command line tool was kind of like difficult, even though it makes the command really easy. I was like, this, I don't know, it's more steps than I thought necessary. So I went with AZ storage upload. The account name is the storage account that you created at the very beginning. The account key is located in your storage account. If you go all the way down to like this part, account keys, click on it. It'll show you like a set of keys, and then you can press show and copy that. And that's just your account key. So yeah, account name is CV for eTutorial. That's my storage account name. Account key is something that I have blocked out. You specify the file that you want to upload, your container that you've made, and then the name of the file that you want it to be in your container. I just kept it as the same name. And then it should upload and say that it's done and give you this like HTTP response, which doesn't really matter, but yeah, it'll tell you the details. Okay, and yeah, there it is in the Azure blob container. Okay, now for VM, yeah.
So for the AWS, you said to do a folder, we had to add like a recursive command. Is that the same for?
Azure has a different command entirely. So they have Azure storage upload, and then they have like Azure storage upload batch, which will copy all of the files in the folder without copying the folder itself. And then they also have an Azure storage directory upload, which copies the folder and everything within it, including other subfolders within it. Good question. Okay, now for the VM side of things, does anyone have any questions about storage? All right, cool. So again, we'll go with AWS first, and then we'll talk about Azure. So AWS folks, we'll go back to your console, click on this EC2 tab. From there, click on Launch Instance. Okay, and then it'll prompt you with, like, do you want to choose an existing image? So an image is like a machine that comes with a bunch of things pre-installed. So if you type in deep learning in the like selection of Amazon machine instances, and then look for the Ubuntu flavor, it'll have every like Conda, PyTorch, Torch Vision, CUDA, all of these things pre-installed so that you don't have to install them manually.
What is an instance?
An instance is just like a VM.
Oh, okay.
Okay, and then it'll prompt you to pick your size. So you can either go with something really, really, really small. You can also go with something like ginormous. But I, for the purposes of like playing around, just typed T3 X large. It's $115 for like the entire duration of the summer school. So like you would never have to worry about overrunning your budget, even if you left your machine on all the time. But like, yeah, you don't want to leave your machine on all the time, all that stuff.
Quick question, is it cheaper to always stop and use the same instance, or it doesn't matter, I can create as many instances as I
You can
want?
create as many instances as you want. It is like certainly more complex to have to juggle multiple instances. But yeah, you're allowed to do whatever. It's like the beauty of EC2 is that like you can have 100 machines running at the same time.
So when you might actually do that is once you have like your code up and running, your model up and running, if you want to try, let's say like a few different parameters for one input, you can actually launch them and run all of those in parallel. You don't need to do them sequentially. But Suzanne's totally right that we have a human capacity for the number of things we can keep track of at once effectively. So that is the bottleneck here.
And I like to start with something like large enough not to be like like you want to be able to iterate quickly. So you want to be able to like have results quick enough rather than wait on a really, really tiny, really, really slow machine. Okay, so after you select your like size and everything, it'll have a field of like, do you need to create a key pair or like selecting a key pair? Yeah, and so you'll want to create a new key pair if you don't have one already. This is just like a way for your machine to tell the VM like I am who I say that I am. So yeah, you just name it, you leave it, or I left it as RSA, and then you create it, and then you'll be prompted. I think it'll automatically download a .pem file. And a .pem file is just a concatenation of a private key and a public key. And yeah, so the private key will like stay on your machine, and the public key the VM will know about, kind of thing. And then once you scroll down and like say, okay, I'm ready to create my instance, it'll say like, okay, your instance has been successfully created. And then there's this like small fine print that says, be aware that you can create a billing alert. And I think that that's like kind of a useful tool just to make sure that you're within like your budget. So I'm gonna go over that really quick. So I press like, yep, I wanna go to create a billing alert. It'll take you to this page. You go down to billing preferences. You click on monitor or manage billing alerts. And then that'll take you to this like CloudWatch page, and you'll press just like create an alarm. And then this will take you to your alarms page, which you'll have none of in theory. And so you press create alarm. Yeah, just go through the steps, press like select metric. And then so I wanted to monitor my EC2 usage. So I said, okay, this is what I want to monitor. Select metric. I wanted to monitor it every day. I think I tried to type in like monitor it over 30 days, but that was too much. So I think that its maximum is a day, which I found interesting. And then I wanted to make sure that I spent less than $125. And then, you'll type in your email for like, if you spend over that amount, how should I notify you? And then describe whatever your alarm is. And then there it is. You'll get an email saying like, this is a newly created alarm. So that way you can just like have peace of mind of how to use your stuff. Yeah. I saw Alex's hand
Okay,
first.
sure. So when we create the key pair, what do we do with it?
So I'll get into that in a minute.
Oh, okay.
Yeah.
When I set up an alarm and I found that I couldn't find the ability to make the alarm unless I was through Virginia in the east.
Oh,
Yours is showing that too.
okay.
I don't know. Is that a
That's a
thing?
good. That's a good point. I don't know the answer off the top of my head.
That seems really weird.
Yeah.
It was very weird.
Yeah.
But you had that experience too.
Yeah, it was like the billing you can only do through North Virginia. And so if you're on a different region and you go on your billing alerts, it won't show. You have to go to North Virginia and then it'll come up. But I read somewhere that it applies across all regions, the same alert.
Interesting.
But your screenshot is showing Virginia. so
Yeah.
Yeah.
It looks like.
So that sounds to me like some weird insidious bug and a good thing for us all. Thanks for pointing that out.
Yeah.
It seems like maybe then the solution is you just look at your alerts in Virginia, but they should show up for stuff that you spend in one.
It will certainly show up for stuff like this region isn't tied to the region that you're monitoring.
Extra weird though.
Yeah. Another, like, I don't know, AWS and Azure have a lot of confusion in them. So it's just another level.
If you didn't put in any metrics, you just put an amount, well, I don't really think I remember putting like EC2 or anything in, but just monitor like
Interesting.
usage overall. I think I just put dollar amount.
Okay. I don't know.
I'll look.
That would be really nice. Cause then it's like, no matter what I do, I only
Yeah,
have to spend
don't bill me.
but yeah, you could also click all of them and just put in a dollar amount. So,
Okay.
Yeah.
Thank you.
okay. So now that we have our VM set up and we have billing alert set up, let's get into this machine. So if you go back to your console and click on EC2 instances, they'll have like this public IP address and then this like DNS name. This is more like readable, but I find the IP address to be more like just easier to deal with. It's a way for machines to talk to other machines. So in theory, your SSH key downloaded or your PM file downloaded to whatever your downloads folder is. In order to like let your machine read it, you'll want to give it these permissions. And then you'll use that PEM file to SSH into your machine. So if you created an Ubuntu instance, you'll do SSH-I for like interactive, and then this PEM file name. It could be, if it's in your downloads folder and you're SSHing not from your downloads folder, it'll be SSH-I and then your full path to your file. And then where you're SSHing to is your Ubuntu machine at this public IP address. And then yeah, also like if you didn't choose an Ubuntu instance, your username might be slightly different. So like with Amazon Linux, it's EC2 user. For other varieties, it's other things. They're mostly findable through Google. Like to say like AWS instance, whatever the AWS type username, but.
If you hit the connect button up there, like at the top of the table, there's a connect button.
Oh,
Just
okay.
refresh.
Yeah.
It'll actually tell you what the user is
Okay,
that is on the machine.
perfect.
There's one note here on the PEM file. Do not ever put that into your Git.
Yeah.
I've been at a previous summer school and somebody accidentally committed the PEM file to Git, and then Bitcoin miners found this online. They're like going through Git, trying to find those
Because they can
files.
use all of your credits.
And they used 60 grand of our credits.
Oh.
So just making sure, take this PEM file, take SSH keys in general, store them somewhere at a secure location within your computer,
Yeah,
just
just
far
keep
away
them
from any
Yeah.
good things, anything that you commit to the
months. This is actually like a really common problem. It also happened to Pietro's lab and somehow no one was keeping track. And I think the grand total was $120,000. That, thank God Pietro works at Amazon and he just was like, we're not paying.
Oh my God.
But it was, yeah, so this is like a thing that just happens weirdly a lot, so just be very, very careful.
Like, where is the where is
On
the
your,
best?
on your computer.
On
like,
your computer
don't-
and don't
put it
in your
anywhere.
GitHub,
Yeah.
like if you're gonna have a folder on GitHub, it shouldn't be in that folder.
Or don't put it in Google Drive even, like.
Yeah,
Okay.
don't.
only on your.
Just only on your
No,
they're gonna steal all of our money.
Yeah.
It's another reason to set up an alert. Track that. Okay.
Sorry, just to make sure, not even in Google Drive, like in our own drives? Is that-
I mean, they recommend having it on the local machine you're going to SSH from. I wouldn't put it on Google Drive because honestly, you should make one of these PEM keys for each machine that you would SSH from, and it should only be for that machine.
It would be as though you had like a passwords file stored.
Like in
somewhere
a,
else.
okay, got it.
Yeah.
Okay, so yeah, we're SSHing into a machine, and then once you're on that machine, you'll need to again do this like AWS configure with your access key and key ID and like region name and all of that stuff, just to get it able to talk to S3 and everything. And then, okay, cool. So then we'll see how you can very quickly run something in Python. So this is just cloning a pre-trained model, or like a repo of pre-trained models. So, and this like Ubuntu machine already has Git installed onto it. So you don't need to do that, which is really nice. And then it doesn't care, since it's a public repository, it doesn't care who you are in Git. So you can just do git clone of this Git repo. And then you'll install all of the requirements. So I just did a pip install of all the requirements. And then it'll go through all of them. And then, so Jason talked yesterday about the MNIST dataset and finding numbers in like using deep learning with MNIST. And then this is just running that on, like running a pre-trained model to find those numbers with PyTorch on something that already exists. So this is just showing like all of those libraries are installed. It can run out of the box, and then it can start training just on a Python file. So this is where you'll be like running your Python files and doing your like model development and testing and training and all of that. Okay, last but not least on AWS is stopping your instances. So once you're done for the day and you like go home, you'll want to make sure to stop it. You can either do this through the command line, but I always really like doing it through the GUI because sometimes it takes a while to cycle. It's like shutting down your machine. So you'll just go to instance state, stop instance. Eventually this instance state will turn from running to stopping and then to stopped. And then at the very end, say like you have your paper published and out, and you can totally blow up your VM, and you have like your Docker instances deployed, and you want to like eliminate this and stop being charged for it completely. When you've stopped instances, it charges you like a very, very, very low amount, but it's still like, I don't know, pennies. And so at the very end, when you're done and you want to clean your hands, you'll just go to terminate instance, and that'll delete it entirely. Okay. So now we're going to move on to Azure's VM setup. That was good on AWS's side. Okay, so the way I found to get images on Azure was through this Azure Marketplace. I looked up like deep learning and PyTorch and Conda and all of these environments, and I found this like data science virtual machine. So you like can look for it in the marketplace, or you could just go to this URL. You press get it now, it'll prompt you to log in if you're not already logged in. And then it'll download, and then it'll say like, oh, do you want to create a virtual machine using this image? You'll say yes, I do, in fact. It'll say, okay, it'll like prompt you to create a virtual machine. Everything related to this summer school is tied to this CV for E subscription. Hold on just a sec. But each of you will create your own resource group within that, just to like keep track more accordingly. So I named this new research group tutorial. You'll give your virtual machine a name, and then it'll have this field for like which instance or which image you want, and that'll be pre-populated because you went through this prompt. Probably need to have a question.
Yeah, what is the like, cause in your like YouTube video thing, you just used like the default model thing there. Do we have to like use?
You don't
this,
have
or-
to, it has a lot
Like
of things.
what is it?
It has a lot of things pre-installed. So it has PyTorch already installed. It has like Python already installed. It is an Ubuntu like flavor of things. So it's just really nice because it has like a lot of things that deep learning models or deep learning like researchers want already there.
Okay.
But you can like start from scratch and then download PyTorch, download Anaconda, download Git, all of that.
It has Git in it too.
I think so, yeah. I'd be surprised if it didn't.
Super convenient. I'd highly recommend going with this DSVM instead of starting from scratch.
What does DS image mean?
It's just for data science image.
What do you mean by image?
So it's just like, so an image on both AWS and Azure is just a machine with a bunch of things already installed.
Oh, okay.
Does it matter if it's the version 20.04 or the version 18.04? Is there a reason why you have 18?
I probably just had 18 because I found it first, but if they have 20.04, I would go with that.
Yeah, okay, thanks.
Do you know if you can change that? Like, cause if I already created a virtual machine using like the default things from your like YouTube tutorial, can I just like change the settings of that one, or do I have to create a new one with this?
I think in order to use an image with it, you would have to create a new one.
But that shouldn't be too bad. Like you can, it's the only, like it shouldn't change because all your code and everything should be on GitHub.
Yeah.
Your data is all going to be in something that you're going to mount to any of these VMs. So if you decide you want to use a different image or start a new one, then once you go to that thing, the only difference is what's already installed on there. So it's like I swap these out a lot. Like if all your code is in GitHub, then you just like git pull and then all your code's there, and then you mount the data and then all your data's there, and then you just have everything you need, and it's super fast.
So when you create a virtual machine and you like choose which one you want, when you use an image, how do you choose like how
Like the size?
Yeah, the size.
Yeah, I think that's the next slide.
Oh,
Good setup. Yeah, so it'll prompt you for like which disk type you want. And then it'll prompt you for which ports you want open. So it defaults to have SSH, that's port 22. I just for ease opened HTTP, which can get web traffic, and RDP, which is just like a way to otherwise like access your, like another port to open. And then I clicked on this checkbox that says delete public IP and all of these other things that it creates for you, just because if you don't delete them when you delete your virtual machine, it might still, it like A, orphans those instances or those resources, and B, like could still charge you for them. I just want to make sure like everyone's not being charged for something they aren't aware of. And then I think I just left like the management as it was. I don't see. Oh, no, it's right here. Sorry, Peggy. To answer your question, it's like right below the data science virtual machine. It's this like select a size. So I selected just 2 virtual CPUs and 8 gigabytes of memory for $70 a month. You can like go further up, but I was just like, that seems.
So the thing that I'm scared about of like creating this is when it says $70 a month, if you work out that that's actually not the one you want to use, have you then like, even if you don't ever use it, you spend $70?
No, it's $70 per month.
It's
But
like,
that's like
if you,
charged by the
yeah, if you
minute
leave it
or
on,
something.
if you leave it on for an entire month, you'll only get charged $70.
Oh,
So if you leave it on like for an hour, you'll only get charged whatever that fraction of is.
Right, okay, so it's like an approximate, like, this will cost approximately.
Yeah.
Okay,
Because
right,
they're expecting people to like create these and then use them for
right,
a year or 6 months or whatever.
okay.
Do we have automatic access to the, like, the NC and NB GPUs, or do we need to request that through Azure, like, for our subscription?
I do not know.
I know for these academic things,
There's quotas, so the
Oh.
GPU machines are quite expensive,
Yeah.
like $800 a month kind of thing.
Oh,
So to keep people from accidentally racking up monstrous bills,
yeah.
they basically put quotas, and I think by default it's like 0, because they really don't want you using them unless you really want to. There's ways in the portal where you can basically request to bump your quota up to 2,
Okay.
and then it's more automated. It's like a support request, and it generally gets approved in like 5 minutes.
Oh, okay.
Yeah. So if you wanna go beyond like sort of the 2, then like I think then they wanna check. But basically, they just don't wanna get, basically I know with someone racking up a bunch of money that they then they can't pay, and then
Yeah.
it's like this whole. But yeah, I don't think it should be, what this isn't, is like, we very explicitly push back against having Microsoft or Amazon's like academic like class
Yeah.
credits. Those are really restrictive. These are just money.
Oh, awesome.
So you're basically just like any business.
Cool.
And so you can request a quota, and there's not like limitations because they're like, oh, it's for a class and you don't want.
In general, most of the VMs you will want to prototype on are gonna be CPUs because they're cheaper. You won't need the GPUs until you're actively getting into the cycle of training models over and over and over again. That's where you're gonna see the iteration time drive down because it's just faster. But if you're just prototyping, what does your data loader work? How does your model just like load into memory? How do you get all your augmentation stuff? That's all CPU. You can use the cheap standard. You can have 2 VMs, 1 CPU, 1 GPU, depending on what you're actually doing. So stick with the cheaper stuff until you're a little more advanced.
For sure. And another question kind of on top of this is, I've only used the DSVMs, but I know Azure's trying to push their like Azure machine learning or machine learning studio
Right.
product. What is that?
So it's kind of like,
Okay.
I can.
It's not dumb.
Okay.
It's just,
It's
they're
for-
trying to, yeah, go ahead.
It's for like people who want to deploy. So it's like for people who like don't know any machine
Oh, okay.
learning. So people who like don't want to code at all can use this like machine learning interface it's like really powerful, but it's for people who like don't have any of this.
It's like a point and click GUI.
It's like a bunch of, it's kind of like SageMaker in AWS. It's really
Oh, okay.
intended to be something for people who like want to use machine learning but don't want to do any programming. And what that means is it's very limited to very specific types of tasks.
Okay,
And we don't want any of you guys using that stuff, because
Totally.
the whole point is that you're learning how to do it yourself.
absolutely.
And that gives you so much more flexibility in terms of like what you're actually able to do. You can change things.
Yeah.
Whereas like they're basically like, do you want to do classification? Like you have to then do like, these are your options.
Cool.
Yeah.
And it's like the machine learning stuff comes with a lot of things that we just don't need, like
Awesome.
deployment and operations management and all like we just don't need them.
Not for prototyping.
Yeah, not for prototypes.
So is it on the next slide, the SSD versus HDD stuff, like what, does that matter?
Yeah, so HDD is like your cheapest option and SSD is your like more expensive option. Like it relates to how quickly the machine can read something on the file system. And I don't think that we're gonna be doing anything like where your machine is gonna need any SSD capability. So that's why I have HDD selected, even though it defaults to the SSD.
So use the standard HDD?
Yeah.
I will say that depending on, like, so if you guys have really large training data sets, or it's like a bit, like, so sometimes bottlenecks in training, actually, if you have a large enough GPU, the bottleneck can actually be file IO. So like your training speed, like you won't even be using all your GPU capacity because your training speed will be limited by how fast you're actually able to read in the input files. And so if you start doing this and like, we're like, your training's too slow. If we want to start debugging, like one thing we could look at is like, okay, well, what if we go to an SSD? Is that going to speed up your training loops? But most of you, that actually probably won't be a factor.
For prototyping, like it doesn't, I don't think it makes sense.
Okay.
Okay, so then you open all these ports and then you say delete everything when the virtual machine is deleted. And then it'll ask you about like management, advanced, and tags. And I essentially just left all of these as the defaults. Like I didn't create any tags. I didn't do anything fancy with the management. So I just like left them blank and left the tags blank. I don't really know what tags are, so full disclosure on that one. But
they're literally just, if you have like 700 VMs because you're a massive company and you need to be able to like filter them or sort them or something, then you can write these tags. But you guys are all gonna have like 1 or 2 things, so you don't need it.
okay, cool. And then we'll just go to create. And then once it's created a virtual machine, it'll say, okay, great. We also created a key pair, which is like the private key and the public key. So you just download that. And then I think it's a .pem file. But yeah. Okay, so once you've created it, it'll say, all right, your virtual machine has been created, and you can find it by clicking going to resources. And then, okay. So I think this was so I tried to look up last night how to monitor price usage in Azure too. Short story is, it's not as easy. And so yeah, I went to cost management. It was like, okay, this looks like a way to create alarms. But when I got into like monitoring usage and everything, our subscription says that we're not able to like manage it. So I filed a ticket with Azure to like try to get access to this. But for now, just like in the meantime, there's another way to monitor usage. So I was able to see last night that like all of these things weren't being used very much. And then like in virtual machine land, and then in storage land, like none of our accounts are being used all that much, which was like nice, but I get not as like nice as the other one with alarming and the fancy system. So I'm just like waiting on Azure's response to that, but I hope to have information for you guys.
There's a separate portal for like institutional subscriptions.
Yeah.
I have the URL somewhere here. I can forward it.
Yeah, that'd be helpful. Okay, cool. And so once your virtual machine is created, Azure also has this connect button, and so you can click on it, and then it'll give you all of the instructions for what you need to do with the downloaded key files, how to SSH into your machine, like what its IP address is, and then what the username is too. Okay, so following those instructions, I gave my PEM files read ability. I SSH into my machine. It works well. I'm in my machine. I similarly git clone the same mnist examples repo. I create a conda environment because that's good practice. Activate the conda environment. Install Torch Vision onto it. I found that the data science image didn't have Torch Vision installed, even though it had everything else installed. It installed fine. And then go into the mnist git examples and then run it similarly to how it was run before. So it can train the model, it can like test it. You can run Python files easily. And then I think that was it. Okay, yeah, and then stopping and eventually deleting your virtual machine. You just click stop right here, and then once you're done, totally done with this course, everything is out, you're like, wanna get rid of the machine entirely, then you press delete. Okay, so here are some links. I also included links to like Azure ML and SageMaker in case you guys are interested, even though that's like totally out of the scope of this class. And then an activity that's like not required, so don't consider this part of your like week or day 2 requirements, but an activity to maybe help understand how all of this connects is to like get your GitHub set up, upload your data to your storage providers, and then alter that homework 0 code that you wrote to point to those, like where things live in those storage containers. So get those URLs set. And then once those URLs are set, to upload those homework 0 Python files to your GitHub, and then download those to your VM from GitHub, and then run those on your VM. And then you'll have something of your very own running on your VM, pointing to something in your storage account rather than on your local machine. Just a little activity. Okay, and that's it.
Subscription, or is this CD?
It lasts, so like Amazon's is until you run out of money,
Okay.
and Azure's is until December 2023.
Does storage in AWS buckets cost over time? Like, are you charged for the storage capacity?
They cost per like upload and download, I think.
Right, okay.
Do they cost per storage?
Yeah, but it's
Quite cheap, yeah.
Okay.
I think it's like on the scale of data that you're gonna have, it's not going, the GPUs are gonna be more expensive.
Yeah. And yeah, we'll be around. You'll have all afternoon to work on it. You'll get slides available to you. So even though I went through it kind of quickly, like they'll be there.
Yeah, 4 hours today. By the end of today, we want everyone to have this stuff good. And like, if it's like after hour 2 and you're like, I am totally fucked, like signal, and we'll like come and like work with you more directly. And I think some of you basically are already done with this. And so, you know, if that's the case, also come chat with us and we can definitely like, be like, here are some things you can start looking at.
Or feel free to help others. Or help, yeah. They're running into things.
Real quick, the lecture from yesterday, since it was cut a little bit short, I'm gonna be uploading the code very shortly to GitHub. I'll send out a link, and I'll be recording the last 5 minutes or so that we just didn't quite get to, and editing it into the video. It'll probably go up at some point, either this week or in the next few days. So